3, we looked at systems, linear systems more specifically. A linear system is when you have two linear equations and you're trying to solve for when they intersect each other. So you could do it by graphing. We're looking for two lines when they cross. So you could solve a system by graphing. And we also looked at elimination and substitution. So I'm going to go through those methods for this Chapter 3 final review notes section. So first step, let's try elimination. When is it fastest to use elimination? It's fastest when x and y, say they're stacked, when you have x and y on the same side of the equation. All right, to use elimination, you have to pick a variable to eliminate, either x or y, and it doesn't matter which one you pick, but sometimes one is easier to eliminate. In this case, y is easier to eliminate because one is already negative. All right, once you pick which one to get rid of, you want to make them match. So you want one to be a 4y and you want one to be a negative 4y. So I'm going to multiply the top by 4 to make that negative 4 happen on the top. So we'll distribute to everything. We get negative 8x. Oh, I don't want it to be negative. I'm sorry. I want to keep this positive right here. So I'm going to distribute the 4. So we'll have 8x minus 4y is what we want, equals 36. The second equation, sometimes you have to change it and sometimes you don't, and here you don't because it's already a 4y, so I'm just going to rewrite it. 3x plus 4y equals negative 14. All right, now we add it together, and the variable that I chose should eliminate, and it does. Y's cancel. We get 11x equals 22. Let's solve for x, so we're going to divide each side by 11. So here x equals 2. All right, now we're only halfway done because we want the point of intersection. We need the y value. So the next part is you choose one equation, you plug in for x, and you solve for y. Okay, so let's do that. I'll do that in black. I'm going to choose the top equation, 2x, and I know x is 2, so I'm going to plug that in. Ugh, this is messy. Let's change that. So 2x, which x is 2, so 2 times 2 minus y equals 9. And then we solve for y. 4 minus y equals 9. A few different ways you can solve this. I would subtract 4 from each side. Negative y equals 5. Let's divide each side by negative 1. So we have y equals negative 5. Okay, so we found the point of intersection. These 2 points cross at 2, negative 5. You can check your answer by plugging in for x and y. So we should do 3 times 2 plus 4 times negative 5. That should equal negative 14, and it does. Okay, so that's elimination, where you eliminate one, solve, plug in, solve for the other variable. We also learned substitution. Substitution is fastest to do when either x or y is by itself in one of the equations. And here, it's not, so we have to get it by itself. Okay, so I'm going to erase this so I have more room to write here. All right, these are the same equations, so we should get the same answer. I'll just show you the other method that we can use. All right, so this one right here, substitution. Let's get y by itself. And this equation is pretty easy, the top equation. So we have 2x minus y equals 9. Let's add y to each side. We get 2x equals 9 plus y. Subtract 9 from each side. So here's our equation, 2x minus 9 equals y. All right, now that we've gotten one variable by itself, we're going to plug it in. We're going to plug it in for y, completely substitute or replace it. So this 2x minus y, we're going to plug in for this y right here. So here's what it looks like. We have 3x plus 4. And instead of y, we plug in the 2x minus 9, and that equals negative 14. Okay, so there's what it looks like. Now let's simplify the left-hand side. We're going to distribute and combine like terms. So distribute this guy. We get 3x plus 8x minus 36 equals negative 14. Combine like terms. 11x minus 36 equals negative 14. Solve. So we'll add 36 to each side. We get 11x equals 22. And again, last step, divide. Okay, so we get x equals 2, which is what we got before. And we should expect the same thing because they're the same equations. All right, last step, the same as what we did above. Choose an equation, plug in for x, and solve for y. You can choose either equation. So again, I would choose the 2x minus y equals 9. I would plug in x is 2, so here's what it looks like. 2 times 2 minus y equals 9. We solved this before, so we know the answer. Minus 4. So you get negative y equals 5. Divide each side by negative 1. Oops, here. Divide by negative 1. So y equals 5. Okay, so again, these two lines cross, and they cross at 2, negative 5 is your point of intersection. Okay. Other things that we looked at this chapter, we looked at graphing inequalities. And I don't have an example here. But in inequalities, when you have greater than, less than, greater than, let me see if I can grab my pen here. Okay, so you have, when you have a greater than or equals to, less than or equals to, or when you have a greater than or less than sign. So if you have an equal sign, that line's going to be solid because the answer can be on that line. If you don't have an equal sign, that line's going to be dashed because the answer can't be on that line. So when you solve, okay, when you graph this, there's two methods that we talked about in class. First is if you know the slope and the y-intercept, you can start with the y-intercept and then graph it using the slope. If x and y are on the same side, you can use something called the cover-up method to solve, where you cover one up, find a point, cover the other one up, and solve, so cover-up method. And then you pick a point, test, and shade. Okay, so when you do this, when you graph a bunch of inequalities together and find something called a feasible region where it's all shaded, like over here, this will help you find the maximum or minimum of some objective function. So this is the linear programming, like the cookies problem that we did in class. And so those steps are identify the variables, write the constraints, graph them, find the vertices, these corners right here, and then you plug into your cost equation or profit equation, and you can figure out which gives you the minimum number or the max. All right, so there's a bunch of examples that you can look at in the final review packet. I'll just review one of, like, how about the cover-up method? Let's see. Okay, so here's linear programming. Let's see. I'll just review this real quick. So the first one, slope and y-intercept. So if the first one, I'll do in blue, starts at negative 7. 1, 2, 3, 4, 5, 6, 7. There's your y-intercept. The slope is 2. I'm going to go up 2 over 1 in each direction. It's going to be a dashed line because there's no equal sign. And then you pick a point, test, and shade. So I'm going to test 0, 0 right here. Is 0 greater than negative 7? And it is, so we shade that side of the line. Okay, so there's an example of that. The cover-up method. So this is where you cover one up and solve, like 4x equals negative 12. X equals negative 3. So at negative 3, I'm going to make a dot. Cover the other one up. So let's erase this guy. So here you have 4y. I use a different color. I used blue already. 4y equals negative 12. So here y equals negative 3 as well. So I'm going to find where y equals negative 3 and put a dot. This again is a dashed line. Oops, I didn't dash it very well. But a dashed line because there's no equal sign. And then you pick a point, test, and shade. An easy point to pick is 0, 0. So is 0 less than negative 12? And that is false. So I don't shade that side of the line. I'm going to shade this side of the line. So our feasible region is this area where it's double shaded right here. It's your feasible region. And what that means is any point in that red area will work for both inequalities. All right, so again, if you have further questions, again, the answer key is online, so you can try these and check your answer. And again, that was review for Chapter 3.